there. We are streaming live now. Jagan, welcome back to life.
So Matt, they were saying about a new house. That it's maybe in my stake or not. I'm like, well, they just split it again.
I know.
Are you in Holbrook?
I am not actually sure. I have not got my resume. But we went to state conference to sit next to Adam. That was
That was not what I was expecting. I was expecting Main Street. So.
Well, because Adam's saying that the state center is no longer the state center. Is that true?
It got zoned into the
other, which is so weird because like you're like as close as you can literally be geographically to.
Yeah, so our whole block. So I think we'll keep the building, but they may have to create until they build a new one, which there's actually one under construction.
First one is Active Directory log analysis.
Michael, if they make me go to a different building. I'm gonna keep going to this building, and if my ward's not in here, then I'm in a different ward. It's across the street, but I'm not gonna drive past 15 buildings to get to my new one.
There's not a closer house.
There's a church, and then there's our church.
And we have that going on actually in our stake, where you drive past 15 buildings to get to the one you're assigned to.
So much growth.
Well, they just split the stake a week ago, so and we're in the new part, so it's gonna be it's everything out to Camp Williams. We're that part.
Wow.
I'm like, no, we're in the built out part.
Yeah.
You're. So, oh no. Yeah, so the Jordan Wills First Ward is not in the Jordan Wills stake.
Love it.
The stake was named after us, and that was created, I don't know, 6 years ago maybe.
So
we're in our third
change.
stake of our house.
Wow. That's not very often you get that much splitting going on. I was talking to my son John, and he said that they created 3 new states this last year in their mission.
Wow.
And I was like, wow, that's fast growing. All right, everyone, thanks so much for coming. We have several capstone presentations this afternoon. We have a little break after this one, but then we go straight for a little while, and then another break, and then one at the end of the day. But we're excited to kick it off with Active Directory log analysis. And gentlemen, I think some of you have attended some of the presentations. You have 20 to 25 minutes to present, 5 minutes for questions. Of that 20 to 25 minutes, do you want us to hold our questions, or if we're eager, can we ask them? All right, perfect.
Or if you have more at the end, we'll take time then.
All right, awesome. The floor is yours.
Okay, so thank you, welcome. Our project is very excitingly titled Log Analysis Capstone Project. I'm Eric, it's Jacob and Nate. So our capstone essentially is based around where I work. I work for the Church Education System Security Operations Center, or the CSOC for short. My boss came to me with an idea for a capstone, in case I was interested, and I was. His idea was we're pretty good at detecting in some areas. We're not as good in detecting other areas. So he came to me with a couple areas he would like us to focus on so that we could tell a better story. We had a lot of data, we just weren't doing much with it at the moment. So the main 2 goals we focused on were to, 1, model normal behavior. So how are certain campuses using these areas, these protocols that we're going to focus on, as well as modeling abnormal behavior. So when attackers use these protocols to exploit a network, what does it look like? What does the actual traffic look like? So the main 3 areas we narrowed our scope to would be NTLM, Kerberos, and SMB. These are 3 protocols really prevalent in Windows environments. So again, we just wanted to increase our storytelling ability on normal behavior and abnormal behavior in those 3 protocol areas. And then some of the tools we used were Bro, it's represented by that eyeball. It's the intrusion detection service that we use. Humio, which is the owl, it's how we filter and aggregate our logs, and then Wireshark to do some packet captures, and Python for machine learning. And just a disclaimer as we go through, we're going to be talking in our kind of like general overall findings from the project, not specific findings, because with this being live streamed and you guys being here, we don't want to share live data. So some of our deliverables we're not going to be able to share with you in this presentation, but we'll mention.
You need a clearance.
Top secret. So this was kind of our game plan for the project and some of the things we wanted to accomplish. Starting with our initial research, we needed to do some research on those 3 protocols that we're focused on to help us understand how they work, what they're used for, and what vulnerabilities they might have. And then step 2 was to actually capture and analyze the traffic related to those protocols, both normal behavior, so we could have a baseline of what normal traffic looks like, as well as running a few attacks so that we could see some malicious behavior and how they might be different. And step 3 was to actually create some static alerts using some of the tools we mentioned, Scripts and Humio, where we could create alerts on suspicious activity that we might have found. And then the last thing was to actually explore machine learning and how we might be able to apply it to our project, specifically using it to do things like anomaly detection to find anomalous network traffic.
Yeah, so let's jump right in and talk about some of these protocols. I'll go over NTLM really quickly just to go over some of the things that we learned, but also just to kind of help you understand what the protocol is so that you know what we're dealing with here. NTLM is an authentication protocol used in Windows. It is an older protocol. It's largely been replaced by Kerberos now, but looking at the network data on campus, we do see that NTLM is still largely used here, so we wanted to still analyze it and see what was going on there. It is a little bit less secure than Kerberos. We found a number of different vulnerabilities. I'll go over a little bit of that. But basically, as an authentication protocol, the way that it works is the server that you're trying to authenticate against will basically ask for something generated by the hash of your password, and then compare that to the actual what's generated by the hash of your password stored in Active Directory. If those 2 match up, they say you must be you get access to the resource. A common vulnerability that is exploited here is that since all you need is the password hash to pass this challenge, if you can get access to a user's password hash, or even worse, the password hash is stored for all of the Active Directory, then you can impersonate anybody on the domain, and that's called a pass the hash attack, and we were able to run one of those and also write some scripts to control against it.
So next is Kerberos. This is the newer kind of off model used in Windows environments. This pushes authentication to the client so that a file server, for example, never has to talk to the domain controller directly. So essentially what will happen is you as a user will authenticate with the domain controller using your password. After the domain controller has proven, you've proven to the domain controller that you are you, it will give you a ticket granting ticket. And then you can use that as kind of a pass to go back to the domain controller and say, hey, I've already verified my identity with you. Now I need access to this specific resource. The domain controller will check the ticket, make sure it's okay, and then we'll send you a specific ticket for that resource so that you can then go talk directly to the file server, and the file server knows it can trust you because the domain controller trusts you. So similar to pass the hash, you can get a hold of that ticket and certain security practices aren't in place, then you can use that ticket to impersonate a user across the domain.
And third is SMB. So this is an important protocol for any Windows network, and it's used for a couple things. First is for sharing files. So anytime you are accessing a maps drive on your network or making a file shareable to other computers on your network so they can access it, then it's going to be using the SMB protocol to do that. And second is for remote administration using something called remote procedure calls. And so this basically allows you from one computer to send commands to other computers on your network, allowing you to do all kinds of things like starting and stopping processes, running scripts, all kinds of things. And it's probably using RPC. And as you can imagine, it's pretty dangerous for your network if an attacker is able to utilize these tools. It can make it possible for them to do all kinds of things like move laterally throughout your network. And one example is the WannaCry ransomware. It's one that's pretty well known, and how it worked is it would infect one initial computer on your network, and then using the SMB protocol, it would be able to infect the more computers on your network from there. So from our initial research, the next thing was to actually capture some traffic related to these protocols. And so we set up a little environment up in the IS lab. And for that, we had a VM running a Windows Server 2012 to act as our domain controller for Active Directory, as well as several different types of Windows, all joints to the domain, and a Kali Linux machine that we used to launch a few of our attacks. And so all of our traffic we would generate in this network, and then we would take the PCAPs and pull them over to a box we had on AWS, where we had Bro installed, which is BYU's intrusion detection system, and we could run our PCAPs through that and look at the output from that. And here are just a few examples of some of the network traffic that we've captured that related to these protocols. For NTLM and Kerberos, we wanted to get some authentication-related traffic, so that was things like joining a new computer to a domain, logging into a domain using a domain user, or failing to log in because you put in the wrong password. You know, we try to think of a bunch of different use cases. And then for SMB, that was things like mapping a network drive and reading shared files and writing to or deleting shared files, as well as doing some of those remote procedure calls. And then having that baseline of normal traffic, we also wanted to look at some malicious traffic, and so that we could understand what that actually looks like on a network. So for that, we did a few things related to SMB and NTLM and Kerberos. And specifically, we ran some attacks, pass the hash, SMB relay, and golden ticket attacks. And those are specifically used to exploit vulnerabilities in NTLM, in Kerberos, and in SMB. So using those attacks, we were able to get a better understanding of the networks and how those attacks work.
So our next step was to do static alerting and log enrichment using Bro. So just really quickly, and we mentioned Bro a couple times, Bro is an open source IDS. It's actually recently been renamed to Zeek, but we're used to calling it Bro. We didn't want to call it two different things in the presentation to be confusing. And Bro is still all over the scripting language, so it's still commonly referred to as Bro. The big selling point of Bro is it doesn't tell you what's bad, but it tells you what's happening. So Bro will give you a really in-depth picture of what's happening network or on your network. And then it provides you the platform to enrich your logs with your own scripts, write entirely new logs, or write out alerts to a log called the notice log based on things that you determine are bad. It's also session-based, so if you see a piece of traffic in one protocol that's really weird or you want to look into, you can then search for the session that it was a part of and get all of the traffic for that session, which is really helpful for investigation. So these are some of the scripts that we ended up writing and putting on the dev cluster here at BYU. I'm just going to go over two of them because we don't have time to demo all of them, but I'm going to demo the hostname entropy as well as the SMB admin shares connection. So let me just pull up our AWS box where we're running Bro. I'm currently in the Bro scripts folder. You can see we have a number of different scripts that we could run here. So I'm just going to pull up, it's a bit long. I'm just going to paste over this first command. After this runs, you should see that we have a couple of new files that end with .log. These are files that Bro just generated based on the PCAP that I ran against Bro. So we're going to take a look at the NTLM .log file. And if I scroll over, you can see the last column right now is success. So what I'm going to do is we're going to run that command again. But this time, to the end of it, I have attached our script, the Bro scripts hostname entropy.bro. So if we list that again and go all the way to the end of the file, we should now see that we've added a hostname entropy calculation for the hostname. So this is basically just is a score of how random your hostname is. So if we come over here, you can see that the YVA capital A, that's the hostname for that specific log instance. So one of the things we found in our research is that tools that are generally used to perform these kinds of attacks will randomly generate a host name. So those randomly generated host names are usually a lot more entropic than a normal host name. So if we add that score to our logs, it's really helpful to us later as we go and start parsing through our logs to find things that have really high scores. You know, that might be something worth looking into. So I'll actually just go ahead and do this a little earlier, but we'll just take a look at the script itself. So this is what a bro script would look like. At the top, in that redef, we're redefining the NTLM record and adding a field to it. And then in this event, anytime bro sees an NTLM authenticate event, it will run this script as well as its own code. What our code essentially is saying is we find the host name, we calculate the entropy, we add it to this new field, and then if the entropy, based on the length of the host name, if it goes over a certain threshold, we're also writing out a notice to the notice log saying, hey, this is really entropic, like it's above 3 standard deviations.
Yeah, so how did you decide on the thresholds?
Yes, we'll get into that a bit later,
okay.
But we mainly did that through the machine learning portion.
Okay.
So just to give a quick example of a notice, we will run this quick command. This takes one of the pass the hash attacks, the PCAP that we captured from that when we ran it in the lab. We're running it against our admin share sumstat. So if I less out the notice log, you can see that we now have one entry. It's for the SMB share connection. And we're saying that 10.3.0.1, which was our domain controller, the admin share on that was accessed 3 times, at least 3 times in 10 seconds. We're able to set these thresholds ourselves. So if I come and say, we take a look at this, we're able to set whatever threshold we want right here. Like the threshold is 3, our time is 10 seconds. So we're able to continually iterate and find our best thresholds based on both the machine learning portion as well as what we're seeing in our PCAPs. So that's kind of our process that we use to develop some of these bro scripts, to write out notices of bad things that we noticed and enrich our logs.
So those thresholds are universal across all machines, not, you don't have it customized right now that a certain server, say in engineering, we already know about, and so.
Yeah, so we can certainly whitelist things.
Yeah.
But you know that, and we did whitelist things, it just takes iterations.
Yeah.
And you also just have to consider, like, bro is really powerful in the sense that we use that sumstat function, and it will literally let you calculate on the fly how many things happen within a certain time frame.
Yeah, that's awesome.
But if you, on a super large network like BYU, if you ask it to do something that's super intensive and is going to have, like if you ask it to track every unique URL, for example, you're gonna blow up its memory just because there's gonna be so many of them, right?
Yeah.
So like you just have to be careful, and as you start to scale up, and bro is like features that will help you avoid some of that massive memory eating or the massive performance issues. You just have to be careful that you're not asking it to do too much.
Yep. Okay.
Does that answer the question?
Sure. Right now it's universal.
Yeah.
Okay, I'm gonna then kind of wrap up by talking about the last part of our project, which was using machine learning techniques to actually analyze the logs and see what insights we could gain. So the input to our machine learning algorithms was the output of bro, which is those logs for each protocol. So we trained algorithms based off of each protocol, basically find the most anomalous traffic. What we're dealing with here, I mean, you saw the logs a little bit, it's completely unlabeled data. So we don't necessarily have on each record, hey, this was part of an attack or some malicious behavior or not. So we're using unsupervised machine learning to try to just gain better understanding about the data itself, as was one of the goals of this project, to provide a little bit of better understanding about what's going on. So basically we were able to limit very large data sets. Some of these protocols, when you download a week's worth of data, is hundreds of millions of records. Impossible for somebody to parse through and look at. But after running it through our algorithms and just identifying what's anomalous, it's really manageable for somebody to actually go through and take a look at. What do we use for this? We use Python. We wrote a lot of Jupyter notebooks that we're gonna then hand over to the SOC when we're done so they can see what we did and continue that work. And we just were running these on the lab machines because they have a ton of RAM, and we we can actually work with these kind of huge data sets on there. So I'm going to get into what we did first. First, as we mentioned, we did some of those thresholds. A lot of our static alerts were based off of, there's always going to be, your hosting, for example, is always going to be so random. But we want to say, what's too much? What's probably not normal? And that's what we use Python for. Basically, just based off of the three standard deviation rule and statistics, we, modeled out the distribution of, in this case, the hostname entropy. But some of the unique value we were able to add by doing machine learning is to say, we discovered that when we did this without any sort of categorization just across all of campus, what we were getting back is that our longest host names were the most entropic. It makes sense, there's the most characters. And so what we decided to do is look at the distribution and break down, okay, we need to look at uniquely host names with up to 5 characters, up to 10, and so forth. And so we were able to assign unique thresholds for each of those levels. That really improved the value of our script. Maybe at this point we're not really able to say this is what it should look like for the engineering department or whatever, but we can say based off of how long the host name is, if it exceeds this, it's probably not part of the naming convention, it's probably randomly generated, and therefore maybe part of an attack. So that's part of the value we provided with machine learning, is just this type of setting thresholds. As Eric mentioned, a lot of these scripts are now running on the dev cluster, so we can tune based off of what we're getting back. If our threshold's getting tripped all the time, we can manually adjust, but this gave us a really nice starting point. Next, what we did is some true anomaly detection. So I'm going to talk about 2 types that we did. First, based off of just numeric data, and then based off of categorical data. Basically, anomaly detection is the process of defining clusters. You choose a number of clusters with this algorithm we use, k-means. That's based off of either domain knowledge or just trial and error, trying to get something that provides some real information. And it determines how close each of your data points is to one of those clusters based on a normal Euclidean distance, the straight line between 2 points. For that reason, it really shines for numerical data because you're calculating these distances. One struggle we ran into is we didn't have a lot of numerical data. Again, you saw the logs, it's mostly categorical. It's IP addresses, host names, things like that. And so we actually went a different approach here, and we first aggregated our data set based off of certain things. For example, we'd aggregate by the origin host, and we'd say, how many other unique hosts are you trying to connect to? Things like that, where we'd actually calculate, we'd engineer some numerical features that we could then use to identify anomalies, not at a record by record level, but by an aggregate level for a host. And what we were able to find by doing this is things that, because we were aggregating, were anomalies on a large scale. For example, we found a host that was trying to connect 200,000 times or something like that over the course of 24 hours to another specific host, most of them being failed attempts. Things like that are what we found with these large, aggregated anomaly detection methods. But we really wanted to look individually at the individual records of what was happening. So we looked at another type of algorithm as well. Dr. Keith encouraged us to actually look at algorithms that are specialized for categorical data. We found a couple. One of them being k-mean, k-modes, which was very similar to the last algorithm I described, except it's not looking at Euclidean distance between clusters. It has a unique distance measure that we wrote that basically says how dissimilar is it to another categorical cluster. And the centers of the clusters are just the most common categories as determined by the algorithm. And what this gave us is basically kind of what I've been mentioning here, where we start out with this green circle, all of our data, way too much for anyone to look at, and then after running it through our anomaly detection, we were able to say, okay, for example, we went down from 1 million rows to, in one case, less than 100. That's something that someone can actually look at. And what the articles we read refer to that as the interesting data. It doesn't even mean that everything in there is like, oh, this is a hacker or something like that. It's just interesting. It's different from everything else and warrants somebody taking a look at it. And we have looked through that to find what could be misconfigurations or people hacking. But the important principle here is that this really gave us a tool to really be able to understand and look at the network traffic better. If we had a little bit, I'll just quickly say, if we had a little bit more time, we would probably retrain these algorithms to remove things that we don't care about so much, so that they focus more on what's really important, and then also implement it into the logs. Put a score in the log that says this is how anomalous this record is, so that someone can look at it straight from there.
So here are just kind of some of the deliverables, things that we're actually going to be handing over to BYU SOC. So in improve their detection of anomalous traffic on the network. So we're going to hand over all the PCAPs that we took. That was something they were really interested in. Just kind of different use cases, how these protocols are being used on their network. And so we have around 50 PCAPs I think we're going to hand over to them. The Bro scripts that we wrote, as well as the Python notebooks of all of Jacob's work on machine learning. And then we also have some dashboards that are written for Humio that actually kind of pull together and summarize some of the information that we learned from our research.
So for some of our lessons learned, first lesson was just we got a much greater understanding of these protocols. We weren't really familiar with them when we started, and it was really interesting to dig deep into how they actually work. We also learned a lot about attacks that use these protocols. It was really fun to, in the lab, actually run attacks against the protocol after learning about them to see kind of what some of their weak points were and how they were actually exploited and how easy or hard it was. We also learned, we got a lot of really valuable experience with tools. Bro is again, it's an open source IDS. It's used by other companies, other organizations outside of BYU, so it's a really useful skill to have in the security space, as well as, a couple other tools, how to use machine learning tools in Python. And we learned that unsupervised machine learning, we do think does have a space within the security realm at the moment. Not to magically find everything bad happening and only the bad stuff, but to narrow your log set from millions of records down to a manageable amount where you could actually look through them. As well as we learned that machine learning algorithms take time to refine. So we would have loved to be able to do this capstone project over a full year, not just the 3 months we had, just because in order to truly get to where we would have liked to be, it just would have taken more time. So that, any questions?
Questions? Okay, I have a couple. And some of this is just, kind of, did you get enough exposure to the algorithms and other things? When you went through and you captured some of these attacks initially,
Mm-hmm.
how often are those attacks kind of stable in kind of their execution? Do they change from different platforms involved? Do they change different versions of software? I mean, certainly as protocols evolve, then you have state changes within there. But how stable are the attacks? And could some of your, I guess would you have had even more success if you could have had captured even more attacks in a wider variety of platforms or versions?
Yeah.
of
So
those protocols?
like each attack, like for the pass the hash, for example,
Yeah.
it's on an older version of NTLM,
Mhm.
right?
Sure.
So if that version has been upgraded, it's mitigated, or sometimes it's just harder to run.
Yeah.
It's not as easy. And from tool to tool, like we could either try to exploit it. There were a number of different tools to exploit each attack, and we did run a couple of different tools just to see the differences, and there were slight differences, but we tried to look for the general things that were always the same. Like for example, when we were looking at pass the hash, we noticed that it's common, depending on your security configurations of your domain controller, for when you run a pass the hash attack, no session key gets attached to the session. So just looking for something like a blank session key, which would normally not happen in an up-to-date NTLM protocol, like looking for that and alerting on it is interesting.
Yeah.
Because it's clearly a sign.
So in that case, you have this heuristic of, hey, here's something weird that's going on.
Mm-hmm.
I think, and kind of where I'm coming from is, even in the lab with some of the 404 labs that we walked through and the packet captures for those, I was amazed by the nuanced differences in, slight configuration changes had on the protocol overall. I'm just curious on how frequently that changes based on this really complex environment that you're trying to study. So
It's a good point, which is why we also kind of wanted to attach the machine learning side.
Yeah.
It's like security researchers can go through and find for this specific configuration, this is what it looks like, right?
Yeah.
But you change that, you tweak it a bit, you move it to a different area of the network, and something changed. And not really sure exactly why.
Yep.
So if eventually, I think we'll get there with the machine learning, but we're not quite there yet.
Yeah. I think with so many script kiddies out there, it's also on the attacker's tool set that they're using, and almost capturing the most common ones.
Yeah, exactly. But
across the
if
spectrum.
you can use the common tools,
Yeah.
and detect the common tools, then you detect the majority.
Exactly.
Yeah.
Exactly.
Like there's one thing that people use for Metasploit to do pass the hash, and that's probably something that's really commonly used.
Yeah.
Because Metasploit is so common. Things
Yep.
like that. So that was one thing.
One of the fears I have is that our students go through some of our classes and they think that everything is so clean, that it all works out always. And I think the pragmatic reality, and I think you've illustrated this with kind of the machine learning that you're doing here, is so often doing analytics is not about being predictive and really certain about the answer, but it's taking this problem space and narrowing it down to this problem space. It really is about filtering and reallocating resources to something, a more manageable set of data. So I appreciated you highlighting that. So tell me what you learned from the project that you'll think will directly translate to your future careers, and if you'll remind me where you're headed after this, I'd love to be reminded of that too.
So I'm heading to Goldman Sachs to do
Mhm.
software development for their networking team.
Okay. And it doesn't have to
Obviously
apply. I'm just curious.
Yeah. Well, like obviously the protocols, the networking side of all of this will be really helpful as I start on that team.
Mm-hmm.
I do want to end up in a more cybersecurity focused role eventually once I get some more network experience.
Yeah.
Bro, I think, is an amazing tool to know how to use. I've already kind of seen that as I talk to people about doing a capstone with Bro. They're rather impressed. So I think that's a really cool tool, and we learn more about the machine learning. Jacob kind of took the lead on that, so he can speak more to that, but that's another really cool tool.
Yeah.
Yeah, I can speak a little bit about that. Part of the reason I focused on the machine learning is because I'm not heading into security necessarily. I'm going to probably to do tech consulting. So I tried to focus on things that I thought might be a little bit more applicable. They do some AI and ML clients, and I wanted to learn the tools. So I wanted to learn Python and Jupyter Notebooks, how to use all those, because I think it's not necessarily what we learned, but I know that those are used. And so that was
Students are now learning that, by the way.
Yeah, that's awesome. It was really great learning experience. Honestly, I think the biggest thing that I learned that is transferable is not necessarily that, I'm going to be using this algorithm for a client in the future, but more so, I started out with something I honestly didn't understand, and I had to break it down, and I had to put it into pieces that I could understand and do some research and provide an output that was valuable. And I think that's consulting right there, is being able to go into a new problem, new situation, and digest it and come up with a problem for a solution, which is kind of what we're trying to do here.
Very nice. Thanks. Nathan?
So I haven't accepted an offer yet, but in a lot of interviews that I've been in, they've been really interested in the stuff we've been doing with intrusion detection systems and modeling attacks, and so it's definitely something that people are interested in.
All right. Perfect. Any other questions?
I know you captured data in the lab. Did you capture network data from the campus? And are you able to say that you found anything that looked like it was being exploited? Are there any compromised computers on campus or anything like that?
We didn't take PCAPs from live data. We thought about it, but there's a lot of it. There's a lot of network traffic, which would be a pretty big PCAP. So we do have a development cluster. Like we have our production cluster for intrusion detection. We also have a development one. So we did throw these scripts up on the development cluster and point a subset of live traffic, like mirror it at it, so we could see our scripts run against live traffic. I'm probably not going to comment on the other half of the question, but we did run our stuff against live data.
What's the likelihood that some of your code makes it to production and kind of the broader landscape.
Hopefully
of
pretty high.
things.
My boss seems happy. We might not bring all of it over because some of
Sure.
it was like we saw something that we thought would be really cool to look at that maybe they're planning on going a different direction with.
Yeah.
But definitely some of it should end up in prod.
Cool.
And for our GitHub or for our bro scripts, we did make a GitHub repo for them because they're not like they don't have any sensitive BYU stuff in them.
Yeah.
Like they're just out there. Like you could tweak the thresholds however you want if you fork it, right?
Yeah.
So we just decided to make that a generic repo.
I'll just make sure that as I launch my attacks, that my entropy is just under the threshold.
Yeah. So those thresholds aren't the thresholds we ended with, right?
I'm just kidding. All right, awesome. Other questions? All right, great job. Okay. 2 o'clock's the next one.